Have you ever wondered what secrets the largest moon of Saturn, Titan, might be hiding? Titan, the celestial body of intrigue and mystery, holds a unique place in our solar system. Unlike any other moon, Titan boasts of a dense, hazy atmosphere. Imagine a moon shrouded in a thick orange mist, so dense that it conceals its surface from our prying eyes. What could possibly be under that veil? But the true allure of Titan extends beyond its atmosphere. It's the only place, apart from our own Earth, where clear evidence of stable bodies of surface liquid has been found. Lakes and seas of liquid ethane and methane, not water, dot its surface. It's a world that both mirrors and defies our own. A tantalizing enigma. As we delve into the mysteries of Titan, let's journey back to the time when this fascinating moon was first discovered. Let's embark on a journey to unveil the Titan. The tale of Titan's discovery takes us back to the 17th century. It's a story of innovation, curiosity, and the unyielding human desire to understand the cosmos. Our protagonist in this tale is Cassini-Huygens, a Dutch astronomer, mathematician, and physicist who, in 1655, set his sights on the stars. As the story goes, Huygens, who was not only an accomplished scientist but also a skilled lens maker, had recently designed a new refracting telescope. This wasn't just any old telescope, mind you. It was a state-of-the-art instrument, a piece of cutting-edge technology in its time. Now, Huygens wasn't the first to observe Saturn, the planet around which Titan orbits. That honor goes to Galileo Galilei, who spotted the ringed planet through his own telescope some 45 years prior. But Huygens had a distinct advantage over Galileo: his new telescope design. It allowed for a clearer, more detailed view of the heavens than ever before. So with his new telescope in hand, Huygens turned his attention to Saturn. It was there, amidst the ringed planet's orbit, that he spotted a faint, distant speck of light. After careful observation, Huygens came to realize that this was no ordinary speck. It was a moon, the first identified moon of Saturn, which he initially named simply Saturni Luna. It was only later that this moon would come to be known as Titan, a name fitting of its grandeur and mystery. Titan, the largest of Saturn's moons and the second largest in our solar system, still holds many secrets waiting to be unlocked. But let's not get ahead of ourselves. Back in the 17th century, Huygens had made a monumental discovery. He had found a new celestial body, a moon not of our Earth, but of a distant planet. It was a discovery that would ignite the imaginations of astronomers and space enthusiasts for centuries to come. The discovery of Titan was just the beginning. The real exploration started centuries later. But that, my friends, is a story for another scene. Fast forward to the 20th century, the Voyager missions brought Titan into sharper focus. Launched by NASA in the late 70s, Voyager 1 and 2 were twin spacecraft designed to conduct detailed studies of the outer solar system. Voyager 1's approach to Titan in 1980 revealed the moon in a new light. It showed us an intriguing world enveloped in a thick, hazy atmosphere. The spacecraft's instruments detected an atmosphere full of nitrogen, much like Earth's, but with an intriguing twist. Swirling in the murk were substantial amounts of hydrocarbons, compounds made up of hydrogen and carbon, the building blocks of life as we know it. Meanwhile, Voyager 2, although it did not approach Titan as closely as its twin, provided valuable information by studying the moon from a different vantage point. It confirmed and complemented Voyager 1's findings, painting a picture of a world unlike any other in the solar system. The atmosphere of Titan, it turned out, was not just a simple haze. It was a complex, dynamic system full of hydrocarbons that could form clouds and even rain. This revelation suggested that Titan might have a weather system and a hydrological cycle, albeit one based on methane rather than water. But for all the tantalizing hints Voyager 1 and 2 provided, their view of Titan was frustratingly limited. The spacecraft could not see through the dense orange smog to the surface below. Despite their groundbreaking findings, the Voyagers left us with a tantalizingly incomplete picture of Saturn's largest moon. And so, as the Voyager spacecraft continued their journey into the outer reaches of the solar system, they left behind a world shrouded in mystery. A world that beckons scientists and dreamers alike with its promise of secrets yet to be unlocked. The Voyager missions stirred up more questions than answers about Titan. In the early 21st century, the Cassini-Huygens mission took our understanding of Titan to new heights. This mission was a remarkable cooperative venture by NASA, the European Space Agency, or ESA, and the Italian Space Agency. It was designed to study Saturn and its rings and moons, with a particular focus on Titan, Saturn's largest moon and the second largest in our solar system. The Cassini-Huygens mission set off in 1997 and arrived at Saturn 7 years later. The spacecraft was made up of two main components: the Cassini orbiter, responsible for Saturn and its rings, and the Huygens probe, which had eyes only for Titan. In 2005, the Huygens probe made a dramatic descent onto Titan's surface, marking the first and only landing in the outer solar system to date. This mission unveiled a world eerily similar to our own, with a thick atmosphere and an active weather system. One of the most remarkable findings of the Cassini-Huygens mission was the discovery of vast lakes and seas on Titan's surface. But these aren't bodies of water like we have on Earth. No, these are lakes and seas filled with ethane and methane, hydrocarbons that are gases on Earth, but liquids in Titan's frigid climate. The mission also revealed Titan's dynamic weather patterns and seasonal changes. It showed us that Titan has a cycle similar to Earth's water cycle, but with methane and ethane. This hydrocarbon cycle includes clouds, rain, and liquid bodies on the surface, making Titan the only body in the solar system, other than Earth, known to have stable liquid on its surface. The Cassini-Huygens mission revolutionized our understanding of this distant moon and left us with a tantalizing question: could life exist in those methane and ethane lakes? The Cassini-Huygens mission left us fascinated and curious about the possibility of life on Titan. Our exploration of this intriguing world is far from over. What comes next promises to be just as exciting as what we've already discovered. As we move forward, our quest to uncover Titan's secrets continues. This intriguing moon of Saturn never ceases to amaze us. The latest findings have added another layer to this cosmic mystery, nudging us closer to the possibility of life beyond our blue planet. Researchers have recently discovered something extraordinary about Titan's atmosphere. It's not just the dense, nitrogen-rich blanket we initially thought it to be. It appears to harbor complex organic molecules, the building blocks of life. This cocktail of chemicals, including nitrogen and methane, could potentially support life, albeit not as we know it. The discovery is akin to finding a prebiotic soup, a cornucopia of chemicals that could potentially give rise to life. It's like stumbling upon a laboratory of life right there in the cold, distant reaches of our solar system. This discovery paints a picture of Titan as a world that's chemically active and complex, a world that could very well be a cradle for life. But that's not all. We're not just relying on remote observations to study Titan. We're sending a mission directly to this enigmatic moon. NASA's Dragonfly mission, set to launch in 2026, has a bold and exciting goal. It aims to explore Titan's chemistry and habitability up close. Dragonfly will fly to different locations on Titan, studying the processes that have shaped this fascinating world. It will probe the moon's surface and atmosphere, exploring its dunes, mountains, and even its subsurface ocean. This mission will give us an unprecedented look at Titan, allowing us to explore its potential for life in a way we've never done before. The Dragonfly mission represents a significant step in our journey to understand the universe and our place within it. It's not just about exploring one moon, it's about unraveling the mysteries of life itself. As we anticipate the Dragonfly mission, we can't help but wonder, what else might Titan be hiding? Titan is a world full of mysteries waiting to be unraveled. This intriguing moon of Saturn has held our fascination since its discovery, capturing the attention of explorers and scientists alike. Its journey from a mere speck in the sky to a fully realized world has been a captivating one. The Voyager missions first teased us with glimpses of its enigmatic surface, and the Cassini-Huygens mission took us even closer, revealing a landscape eerily similar to our own. Methane lakes, a thick atmosphere, and a possibly active subsurface ocean have all added to Titan's allure. Our latest findings have only deepened the intrigue, suggesting the potential for some form of life on this distant world. And with future missions already on the horizon, our understanding of Titan is set to grow even further. As we continue to explore Titan, one thing is certain: its secrets are a testament to the endless wonders of our universe.